Hello everyone. This question has been taken from Olympiad Pathfinder. Multiple choice question number 25 and related to Newton's law of motion. The question is, a block rests on a long plank that is moving with a constant velocity 2 meters per second on a horizontal floor. Coefficient of friction between the block and the plank is 0.1. If the plank starts decelerating uniformly and stops in 0.5 seconds, what is the distance led by the block on the plank? Acceleration of free fall to be taken as 10 meter per second square. And there are four choices. So we have to select the correct choices. Okay, so in the question, it is given this is the plank, the bigger one is the plank, and it is going on a frictionless surface with 2 meter per second. A block is kept on this plank is also moving with the same velocity 2 meter per second. So now both the block and the plank are moving with 2 meter per second. So there is no relative motion between the block and the plank. Okay, so it is moving as if block is intact with the plank. Okay, so let us solve this question. I have made a rough diagram for your convenience where it is saying that now when the plank starts retarding, means start getting slowed down because of Newton's first law of motion, the block will continue to move in the positive x direction with 2 meter per second, but this surface is rough, so an friction force in the opposite direction to its motion will start working on the block, that we have shown it as F, and because of this F, a retardation has been set up for this block, which we have taken it as A1. We have shown it as A1, right? And the plank has, it has been given in the question that the plank itself is retarding with A. Okay, so this is what we've shown here. Okay, so let us make the free body diagram of the block. If you see which all forces are acting, so you can see that weight of the block will be acting downwards. Normal reaction from the surface of the plank to the block will be in the upward direction, that is N. A1 we have shown the retardation of this block. Small f is the friction force, and this 2 meter per second is the velocity at which it was moving initially before this friction force in opposite direction appears. Okay, initially what was happening? Since both are moving together, so friction force was enabling this block to move together with the plank with the same velocity. So friction force was acting in the forward direction. That is why it was moving with 2 meter per second together with the block, with the plank. But when this plank started slowing down, so this, as per Newton's first law of motion, was continued. So we'll continue to move with 2 meter per second. But this one, this surface is rough, so this will provide a friction force now in the opposite direction to slow it down, because the relative motion between the block and the plank has set up, and block is moving in the forward direction relative to the plank. So in opposite direction, the friction force will act on the block. So that is what we have shown it here. Okay, so now we should write a Newton's law of motion on block along the x direction. It is very simple. Okay, since only friction force is acting, so A1 we can directly write A1 is equal to F by mass of the is total force acting on the block divided by the mass, and from there we got A1 as K into G, right? We know the value of K is given 0.1, and G, it has been advised in the question to take as 10. So A1 is 1 meter per second square. This is a simple calculation. Now if we write equation of motion for block, now we know that acceleration, that retardation A1 about the block. So we can write final velocity square is equal to square of the initial velocity minus 2 into A1. A1 is the retardation, so that is why negative sign has come here, into we have assumed that it has moved an S1 distance in the forward direction from the moment when it started, when the Planck starts slowing down, and finally it speed dropped to 0, so that is why we have taken it as 0. So from here we obtained S1 is equal to 2 meter with respect to ground. Okay, because this force we are observing from the ground. Okay, so this motion and equation of motion what we are writing is with respect to the ground. So with respect to the ground means an observer standing on the ground will see that this block has moved a distance of 2 meter, okay, in the x direction. But during this period, the Planck also has moved in the forward direction because it is retarding with acceleration, with retardation magnitude A in the negative x direction, right? So if we write the equation of motion for the Planck, so we can write final velocity is equal to initial velocity minus A into T. Minus sign has come because A is acting opposite to the direction of the velocity. Okay, A into T. Uh, regarding T is given as 0.5 seconds because it has stopped. So in question it is given that the Planck is stopping in 0.5 seconds. So we are utilizing that 0.5 initial velocity 2 was given. So A from here we could get it 4 meter per second square. Okay. Now we have the acceleration and we are interested in knowing how much distance the Planck has moved in this 0.5 seconds when the Planck came to stop. So we have used that equation that final square of the final velocity is equal to square of the initial velocity minus 2 into A into S. Okay, minus sign come again because A is acting negative to the velocity in the negative direction of the opposite to the direction of the velocity, and final velocity is 0, so we have written 0. So S from here we got 0.5 meter. It means the Planck till it came to stop, it has traveled a distance of 0.5 meter in the x direction. Okay, and the block moved a distance of 2 meter in the x direction before coming to stop. So overall distance which the block has moved relative to the Planck will be 2 minus 0.5 meter, that is 1.5 meter. So option D will be correct. So hopefully you understood the concept and there is no issue. In case of any doubt, please do not hesitate to write any place, anywhere, any point. I will come back on that. I will explain. Okay. Thank you.